Hello guys, welcome back to my channel, and this time I'll be introducing you with my new Formula 1 hypercar. Most of the Formula 1 cars look like this, and they have complex aerodynamics, and fuel tanks is in the middle of the car, and also engine is the backside of the car. But I chose this design over this design because of my own reasons. A Formula 1 car is made of lightweight aluminum alloys, and Mercedes is now using carbon fibers. But in Simplerockets 2, we simply don't have that opportunity. So my first issue was the weight. Okay, now take a look at the cockpit. Due to the cockpit canopy, the height of the cockpit is too much, but I have to reduce the height. So if I remove the canopy from the cockpit, the airflow becomes turbulent. And obviously I can create a safe air bubble for the driver without the cockpit canopy. So my second issue was the aerodynamics. And my third and last issue was the speed, or more specifically the wheel. To solve the first issue, I avoided to add more and more parts, so the part count is reduced and additional weight is reduced too. Now the most important issue is aerodynamics. We have to encounter lift force, Magnus effect and aerodynamic drag here. Any wheel rolling forward faces a Magnus force which is downward, so that's why we need more power to roll the wheel. Now we can't oppose the Magnus force, but we can undo the Magnus effect by covering the wheels, so that's why I used that cover in the wheel. Now comes the lift force. To make the car most efficient, we have to generate enough aerodynamic lift so that the car reaches its maximum speed. There are two ways to generate lift. First, to lower the amount of air passing under the car, and the second way is to increase the smooth curves just above the center of mass. So I reduced the bypass air by lowering the car, and using the wings I increased the lift force. And at last, the drag force. The drag force comes directly from the air resistance, like the air is directly charging into the front wheel covers, so the front wheel will face a downward force. We can overcome the drag force by simply lift force, but as the car accelerates, the dynamics become more and more complex, so we can't rely on just lift force. So that's why I used spoilers behind the car. The spoilers will add more lift and more resistance to the rear wheels, and that will make the car to stay stable. Now there is one more problem, and that's about the spoiler. If the spoiler disbalances the balance between lift and drag force, then the performance will change dramatically. Like if the drag force becomes greater, then the front wheel will leave the ground, and if the lift force becomes greater, then the speed will decrease. So that's why I tilted my spoiler wings 5 degrees backwards to balance the lift and drag. And our last issue is the wheel or the speed. To increase the speed, I have two different ways. First is to increase the wheel torque, and the second is to magnify the wheel torque by using an electric motor. So I used the default motors in the rear wheels with maximum torque, and reduced the gear ratio of all the four wheels as much as I can. And our car is ready now. As some extra features, I added roll wings and yaw wings to make better turns, and placed my battery under the car.